All right, let's go ahead and get started. Thank you for those who joined. James, thank you for coming. I know that it's middle of the day, so it's kind of a hard time to get here. This is week 4, so this is our final week, and I got to be honest, since this is the first time I've ever taught this class here at Independence University, I've really enjoyed it. I've enjoyed the first 3 weeks, and I've enjoyed this week also. Getting to know each and every one of you, because I have taught 2 sections of this class, this mod, so I've gotten to know each and every one of you, and it's been really fun. I've enjoyed the discussions. I've enjoyed reading your posts, your assignments, and your assessments. This week is going to be the exact same as last week, or the previous weeks, where essentially we're going to go through the slides, and I'm going to tell you a little bit more and try to interject a lot of real-world experience into the slides and tell you a little bit about it, and in terms of programming versus just basic programming logic and design. And then at the very end of it, we're going to go through the final assessment also, so you'll have at least some semblance of how to work through it. So again, I do need to mention before we go into the section that for those of you who are going to be watching this in the recorded session, please do not forget that if you haven't submitted your assignment 1, 2, and 3, or your assessment 1, 2, and 3, please go ahead and do that. I'll still accept those, and I'll still grade them. So just please submit those so that you don't lose any points. And also for this week, don't forget that you have a career integration quiz that we like for you to fill out. It's a quick 15 points. It's easy 15 points. All you have to do is fill out 3 questions. The first question is primarily, what did you like and dislike about the course, and how can we improve it? The second one is about me, the instructor. How did you like the instructor? What could the instructor improve on? What could the instructor do better, or how did they do overall? And then the third one is about the book and the assignments and the assessments. What did you think of those? Could they be improved? Did you learn a lot from them? Just boilerplate information. How did we do as a class to help you? So, and they don't have to be that long. They can be 1 to 2 sentences. They can be a paragraph if you choose. But they don't have to be that long, and they do have to, in essence, capture how you felt about the course. I do get to read them, so that's a good thing about me, or about the courses that we have. I do get to read those, and I do get to learn from them, so that if there's something I'm not doing right, or something that another instructor does that you want me to incorporate, I'll be glad to do that. Put that down, and I always learn from at least the question 2 experience, because each student, I've got 15 students in one of the sections, and I've got about 22, 23 in the other. And every time I teach these courses, I learn something new, because my learning or my teaching style might be totally different than someone else's. So it may be a lot easier for you to understand something from another instructor. And I really want to get better at teaching you all and helping you through. So make sure that you tell me what I can do wrong, or what I've done wrong, what I can do better, or what I did good on or great on. Just let me know. All right, so today what we're going to go through is file handling as it pertains to basic logics. Again, I do like to start my slides off with my instructor information. Again, my name, my email, my phone number, and my Skype information. Again, like I've said in the past 3 weeks, and I will reiterate again, The telephone number does receive text messages, so if you want to shoot me a text message, that's completely fine. Also, since it is week 4, I do want to mention that I do this for a living. I do work and program for a living. So if you get into your upper level classes and you do have issues or concerns that you can't get your instructor to help you with, or the instructor hasn't returned your calls, or this, that, and the other, life happens, things get in the way, and you just don't have a chance to get in contact with the instructor. You do have my telephone and my email. Please go through. You can email me, you can give me a phone call, and I'll be more than happy to help you out. All right, so file handling and applications. Before we get started, James, since you're here, I hadn't forgot about your network diagram. I know you sent me an email about it but it's been about a week ago now. I've been doing a little research and look for an email from me this week. All right, so file handling and applications. The key objectives that we're going to talk about in this particular chapter is going to be computer files, the data hierarchy and how it works, performing file operations such as reading, writing, and editing, sequential files and how the control break logic works, what a merging sequential file is, or how to merge sequential files, how to master and transactional file processing, and random access files, how to rotate those on a periodic basis. So let's talk about how to understand computer files. First off, there's 2 sets of file structures that we do talk about, or there's 2 sets of situations that we talk about. First is RAM, things that are stored in random memory, random access memory, or RAM. It's very temporary storage, it's very volatile, and it's a good place to store our variables. Let me put it into a little bit of perspective really quick. When you're working with RAM or working with random access memory, if you're working on a program that has a lot of variables, as you've noticed over the past couple of weeks in our pseudocode, we've introduced more and more variables into our code. Well, all of those have to be stored somewhere, and it's always stored in random access memory, or RAM. Now, that's an excellent thing when you're working on the fly. You're doing things very quickly. You have to do quick computations and return back to the screen or the user really quickly. Excellent. However, if you're working on a system that has been known to crash, which I'm going to be quite honest with you, this is going to happen to you more times than you can count. Yes, James mentioned blue screen of death. Those do happen, and it is horrible. That's why they say, or that's why I put into the slides, that it's very volatile, because at any point in time, that system can go down. And if it goes down, you are completely out of luck. All of that information you stored in memory is now gone, dissipated. Right, James says save, save, save. So a good part, or a good comparable way to work around RAM is permanent storage. Good thing about permanent storage is it's non-volatile. It doesn't change that often. And it's what we call hard drives, or the newer style hard drives are the flash hard drives, or the solid state drives. Those are different types of file structures or data structures that we can work with. Right, James, those are good examples. Thumb drives, jump drives, external hard drives, internal hard drives, all of those are permanent storage or some semblance of permanent storage, meaning we can take it from one computer to another and make sure it works properly. For instance, I can take a list of users from one computer, put it onto a flash drive or a thumb drive, whichever way you want to call it, walk over to another PC, plug it in, and it will still be there. However, if I've pulled up in a program a list of users and I don't save it, if I shut the PC down and try to reboot it, it will not be there. That's the difference in volatile storage versus non-volatile storage. So there are multiple or two different types of files that we do talk about when we talk about non-volatile devices or non-volatile storage. The two types are text files and binary files. Text files we can see very easily. You can open up a text file kind of like a batch script or an Excel file, or a good example, James, an INI file, an initialization file. Those are quick, easy, plain text files. That's the word I was looking for, plain text. Meaning when you open them, you can see the information. Now the difference is in binary files, you can't see that information. It's scrambled. It does a particular task. For instance, an executable file. If you were to right-click and edit an executable file, it looks a little different. It looks hard to read, not very understandable. James, you're asking if it's encrypted. It's not exactly considered encrypted so much as it's considered compiled. If it's a compiled language, it's going to be in a binary file, which means it can be executed at any point in time. So some of the key characteristics of the file types that we do like to talk about, one is the name, the time that it was created, who created it, when it was last modified, and the size that's measured in bytes. Right, like DLLs. DLLs are hard to read. So since we talked about files and how they are the two different types of files that we have, let's talk a little bit about where we store those files. We usually store those files in what we call directories or folders, depending on the operating system that you're working with or the particular person you're talking to. If you're talking to an older style Unix or Linux administrator or programmer, they're probably going to call them directories. If you're working with a new non-host Windows or Mac style developer, you're going to hear those people call it a folder. It's the same word, it's the same thing. The difference is the way they call it. Now, talking about that really quickly, directories and folders. Even though I'm relatively young in my career, I still call it directories. And the reason I call it directories is I've been working on a Unix style or Linux style operating system for the better part of 8 years. And it's just been ingrained in my brain that it's a directory structure, not a folder structure. And then you work with, or then we start talking about, okay, we have a file. Let's say, for instance, the one we have here on the screen, payrolldata.dat file. That file is stored in a series of directories or a series of folders on the C drive. Right, James, like a tree structure. It's stored in the C drive on the logic folder inside sample files, and that's where the payroll data file is found. So the path is the combination of the drive plus the hierarchical structure of the directories where the file resides. So if I said I want to know the file path, essentially I'm asking if I want to know the file path for the payroll data file, it would be the location. You're right, James. It would be C drive, logic, sample files, and then under it would be payroll data. Now we could go a step farther and we could say the year and the month attached, or the year and the payroll cycle attached to that payroll file. So we may go one or two more directories deep. James, you're asking, or file attribute. What do you mean? Oh, yeah. Okay. So when you're searching for the file, you're looking for the attributes of the file. Right. So we're still trying to understand the data hierarchy and how it works. So there are a couple of key components that describe the relationship between the data and the particular file itself. First is the characters that are used, the fields that are inside of the particular file, the records attached, and the number of files that it has. That is the data hierarchy. We can also throw in the path or the location to that particular data structure. So there's a couple of key features that we can work with when we are performing file operations. First and foremost, you have to always declare what you're doing to that particular file when working with a data file. There's two key things you can work with. You can use input or you can use output. Whenever you're using input, you're adding to the file. Whenever you're saying output, you're always getting data from the file. And when we're working with these three sections, declaring, opening, and reading, declaring a file, essentially, James, you're asking, what is it the same as creating? What you're doing is essentially creating the file handler. Again, remember the section here is file handling. That is the file handler, where we're going to associate that particular file to the directory structure that we're using, which is where opening a file comes in. We've created or we've declared the file handler, input file employee data. Now we have to open that particular file, employee data.dat. Yes, the declaring would be a file association. We're associating the file with that particular system. Then you get into reading from a file. Once you've declared it and you've opened it, then you can read from that file. You can read the input name, you can read the address, the pay rate, the date, anything that's inside of that file you can read from, or you can write to. So think of performing file operations as once we have that particular file and we opened it and we're starting to read from it, we can declare different variables such as the name, the address, and the pay rate associated to a particular person. And once we're reading that file or reading that information in from the file, we're going to store that into our volatile storage, our memory. Once we store that into memory, we can then decide what we want to do with it. So if you'll look on the screen here, you'll see we're reading from the disk or from the non-volatile storage, such as a flash drive, a hard drive, or thumb drive. We're reading the name, the address, and the pay rate. We're pulling that information in, and then we're passing it to the name variable, the address variable, and the pay rate variable, which we can then use at a later time. After we've gotten the information that we need and we've performed either some updates or edits or some computations to that file, say for instance, let's go back really quick. We've taken Matthews, and we've got his address and his pay rate. What we want to do now is once we've got that into memory, we want to update his pay rate. Say he's done an excellent job for us over the past couple of months. Now we're going to update his pay rate. We're going to make it $18 instead of $17. So what you would do is you would do an output. You would write out to that particular drive or structure. You would then write out his name, his address, and his updated pay rate. Once you're done working with the file, the employee data file, we can then close the file. So you have steps that you go through. You have your declaration, you have your opening, you have your reading, your writing, and then your closing. Let me say that again. You have your declaration, give your declaration, your opening, your reading, your writing, and then your closing. Those are key features you need to work with or remember, because that's where that's the important parts of working with a file. Once you declare it and you open it, what do you want to do with it? Do you want to read from it or do you want to write to it? Once you're done with it, you can then close it. Right, closing is considered saving the changes. So let's take a look at this in terms of flowcharting and pseudocoding. We've got our first file, right? So we're going to start and we're going to declare our input and our output file, as evident by employee data and update data. We're going to set all of our variables or our constants that we're going to work with. Once we set all of that information, we're going to call a particular subroutine or subprogram that we've written called housekeeping. Housekeeping essentially is going to open the employee data file. It's going to open the update data file, and it's going to input all of those pay rates, the addresses, and the names into the employee data section. And it's going to return back the first time. So it reads the first line, and then it goes, is it the end of the file? If it's not, it's going to go into what we call a detailed loop or another subroutine. The next subroutine says detail loop, take the pay rate, it's going to equal the pay rate plus a raise. Then it's going to send that output to the updated data file, and it's going to make sure that the input is from the employee data file. Then it's going to return. Then it's going to continue over and over and over until it's finished. If it's finished, it's the end of the file, there's nothing else to process. We then go into our finish subroutine, which is close employee data, close update data, and stop. It's a very simple style program. It's opening two files. It's looping through to make sure the file is done. It's doing some sort of computation, and it's finishing, or it's closing and finishing. So how would we write that for pseudocode? Well, again, we would have our three subroutines, which is housekeeping, detail loop, and finish. We would say start, we would give our declaration, just like we did in our flowchart. We would say our input and our output file, employee data, along with our update data. Again, we would set our variables. Then we would get into our process, just like we did in our flowchart. We would say housekeeping, open the files, and input that data into our employee data array or our employee data structure that we've created. Then, while we're not on the end of the file, it takes the pay rate on the next line and it adds $2 to it. It then sends that to the update data file, and it continues until it's finished. Once it's finished and it reached the end of the file, we then call our finish subroutine, where it closes those two connections or those two handlers, and it stops. James, you're asking, so the loop would be for a different employee. Yes, it would be for a different employee every time, or a different record in the list. Okay, so working with files. The biggest part of this is a program that performs a file operation. You always want to have a backup file. In case something goes wrong, you can always copy back from the parent information. So we have what we call a parent file and a newly revised copy, which is called a child. So we take the parent, we copy it over to the child, and then we do our computations and our changes. And every time we open a new handler or open that handler again, we're going to copy that parent file or the old child back to the parent. Does that make sense? The child of the last updated version becomes the parent in the new file structure. And yes, James, you're right. You can see that when you're working with Word, Microsoft Word. So understanding what a sequential file is. So records are usually stored one after another in a sequential file structure. A good example of that when working with sequential files is Microsoft Excel. Microsoft Excel works in a sequential fashion. Each sheet is stored from A all the way to ZZ, and then it hits a new line, A to ZZ, all the way down to 65,536 particular rows. That is a sequential file. It's also like a numerical list on a Word document. It's sequential. It goes one after the other. Then we get into what we call a control break, which is considered a temporary detour in the logic of a program. A control break is essentially a change in the way we work with our particular data structure. You can have a single level control break, or you can have a multi-level control break. Essentially what happens is you do some sort of computation, just like we did or we saw with housekeeping. It opens the files and then it goes into a loop. Once that loop is done, it hits a control break where it says, okay, everything you wanted me to do is completely done. What do you want me to do? It says, and then we give it a command to say, you're done, finish. That's the control break. So a single level control break would essentially be, if you're looking at a file, let's say for instance, this particular file here, we have a company's clients by state of residence. The control break would be, here would be a space or a new line. Every time it hits that new line, it knows to do the computations on these particular systems or this particular setup. So it would have a control break after the 3, after the 5, and after the 1. Right, James. You're saying a different state in this case would be the control break. Yes. So some examples of control breaks in reports are essentially all employees listed in ordered by department number with a new page stated for each department. So basically, after each department, you're going to have a brand new page. That's considered a control break. Or if you're using Microsoft Word, we call that a page break. So another example would be all books for sale in a bookstore that are listed in order by category. So with the count of the following category being control break. And then lastly on this, an item sold in order by sale date would be a control break. Okay, so looking at a basic control break or mainline logic. Again, we're working with our in files. We've set a title, a column header, and we've given a string of old state. So we're going to run our get ready subroutine, which says we output our file or title, our header. We open the clients by state. and then we start inputting their information. But if you'll notice, we're assigning the old state value from, or we're assigning the state value to the old state from the previous section. So after get ready, it runs the produce report section. The produce report section is actually going to show or spit out or display out all of the information inside of that client data file. And then it's going to finish up by just closing everything out. So we can add in what we call a control break, where in the produce report, if the states are not equal, again, that's a comparison operator. If they're not equal, then we say output count for the old state. It's going to print out the old state and the count. We're going to reset that counter to 0. And then we're going to set old state equal to the new state. And then we're going to keep going. Is the old state the same? It is. Output the information, increment by 1, input it into the end file. Then we go back again. Is it the same? If it is, we'll continue until we hit that control break of yes, it is. And we break out and we reset our counters. And then we finish up. The finish up just says count for the old state to finish the last one and close the end file. We can also merge sequential files, so essentially merging two files together. So we can combine two or more files while maintaining sequential order. An example would be looking at a file of current employees in the ID number order and a file of newly hired employees also in ID order. So essentially, if the files, say we have all of the old employees up to number 10, and then we have the new employees up to number 20. We can merge those two together and can keep going and iterate through them. Yeah, James, you're saying, or maybe two different people working on the same type of inputs. You can, yes, essentially you can work on two different. Think of it in terms of like an assembly line. I do one job, you do another job, but at the very end of it, it all comes together to make one product. And there's two conditions required to merge a file, or to merge files together. Each file has to have the same record layout. You can't add columns to one that you do not add to the other. And they have to be sorted in the same order based on the same field structure. Again, they can't be changing based on a whim. They have to be a clear, defined section. That's a good example, James. The database structure has to be the same. I'll give you, for instance, or an example in working with merging files. I know I've talked about this before, where I've been working on validating time cards over the past couple of years for the Department of Defense. We get a file, essentially, every 2 weeks, a payroll file. Or we get about 100 to 120 every 2 weeks. And I have to take all of those files and I have to merge them together. So again, I have to declare the file. I have to open all 100 or 120 files, read all of those files together sequentially, and input those into a database table. If by some chance one of the files has the wrong structure attached to it, meaning it has one extra column or one column out of place, it will not work. It will kick that file out and keep going. So essentially, those people will not get paid that week. Yeah, so essentially, if it's empty, that's fine, as long as there's a placeholder for that particular value. So once it's done processing those files, it closes the files, and then it removes the files. So we now have a snapshot in the database of those particular files. We no longer need the files for recording purposes, but we do have a snapshot in case we are audited, essentially. And for the first year in working with that particular design, as a programmer, I had to account not only for missing files or files that had the wrong data structure, columns and records, I had to account for all of that. So years 2 and 3, it was more of a maintenance mode where they would send us a file and we would get something we had never seen before. So we would have to essentially code for that. Yes, James, either create new fields in those cases or change the way the fields are accepted, or drop fields. I've even had to do that also. So a good example, again, talking about merging files. We're going to merge East Coast and West Coast together. They have they have 2 columns, and they have the same style of information, a string on the left and a number on the right. By taking those 2, we can merge them together and make the same data types. Make a merged string field and a merged number field. So another key feature to make sure you understand is when working with mainline logic, you always have to look for the end of the file. So with 2 input files, you must determine when both files are finished. So you have to define a flag variable to indicate that both files have reached their end of file, or EOF. Once that's defined, you can then check for it. Once it's checked, you can then handle it gracefully. You also must define the 2 inputs, and you have to be able to read one record from each input file at a time. So for instance, looking at a merging file process, we have our East Coast file, our West Coast file, and our merged file. We take our get ready process, and then we merge the files together. So it says, okay, get ready. The first get ready process does something, which it'll show us in just a moment. And then at the end of both files, merge the records together or finish up. If there's still more in the file, continue. So the merge records would say, is it East Coast or West Coast? If no, output. If yes, output. Meaning, is that name still there? If we don't have a name there, finish up, you're done. Right. If it's done, merge them together. Now let's switch gears really quick and talk about a master and transaction file. The master file holds the relative permanent data, and the transaction file contains the temporary data to be used to update that particular master file. For instance, with particular files that we get, we have a master table that we work with, and we have a transaction table that we work with. Every 2 weeks, we get new files. Those are what you would consider the transaction files. Those transaction files are then used to look at the master table or the master file to see what needs to be updated. Right, the time cards. Every time since you do not want to change the person's first name, last name, their city, state, zip code, social, all of that stuff stays permanent. But what changes is their hours worked for each individual week or day or hour. Those are the transactions that change and need to be updated. Again, examples, a college maintains a master file of all students and a transaction file for each course registration. So every time we go through a new module, we have to have a new course registration file. And there's two approaches that you can work with when working with a master file. One, you can change the information in the master file, which means you've effectively overwritten the information that was there beforehand. Or you can do what a lot of people do, we call it versioning, where you copy the master file and you change it to a new version. Right, James. Either way, you overwrite or copy it and version it. So then looking at our housekeeping and our read master section. The housekeeping section for a master transaction program would say open the file for both customers and transactions, and a third for updated customers. It'll read the master, and it will check for the end of the file. Once it's done, it'll then read the transactions. So it'll read the transactions file until it's done. Then it will check and see if they're both finished. If they are finished, it's going to return back to the main section. So you'll notice over the past couple of weeks, we've added decision structures, we've added repetition structures, and now we're adding what we call modularity or modules, where you can have subroutines being called from the master routine. And then you have your update records process, where it updates the transactions. If the transaction customer is equal to the master, then it's going to take the master and increment the transaction. Else, if the transaction is greater than the master, just output that information to the updated file and then read the master again. Else, output there is no master record for this person and just read the transaction. And then check to see if it's the end. If it's the end, finish the program. So looking at this in terms of so you're asking if it's no master record, what's it going to do? It's just going to update the particular master file, the new updated customer file with the particular information. For instance, looking here at the master, we have 100, 102, 103, 105, 106, 109, and 110. It's looking through here and it says, okay, we have something for 100. So we're going to take that total of 1,000 and we're going to update it by 400. We're going to look again in the transaction. Do we have a 102? No, we do not. Just print that total. Do we have a 103? No, we do not. Print the total. We have a 105. Increment that by 700. Then it says, okay, do we have a 108? We do not have a 108. So we're going to add that 108 to the new master file. Then it's going to look and say 110. We do have that. Increase that to 900. Yes, essentially like a customer account. It checks, do you have an account? If you do, it updates it. If you do not, it creates one for you. And then we get into what we call random access files, such as interactive programs, real-time applications, and batch processing. Batch processing allows us to use sequential files, or it also involves performing the same tasks with many records over and over and over. When we are validating and creating time cards, we're doing it in what we call a batch processing style. You also have a real-time application where it requires the records to be accessed immediately while a client is waiting. For instance, you want to be able to instantly access your bank account when you go to the website. That's a real-time application. And then you have interactive programs, where the program that actually interacts directly with the user's request. Yes, a batch file essentially runs several operations in one click. You're absolutely right. With random access files, you can have records, so they can be located in any order, any fashion. You can have one of two different types of accesses, instant access or direct access. You always have to declare the variables you're working with or the files that you're working with, and you always have to seek where they are. So you have to know the directory path you're looking for. If you don't, you have to find them. That's where random access comes in. That's why when you upload such a resume or a file or a video to YouTube, Facebook, or any other media outlet. You have to find that particular file. It's a random access file, something that the infrastructure or the interface doesn't know what to do with. But you as the user do. So you can upload that particular file in an interactive mode where you are telling it, hey, I know this is a WAV file. Right. James, you hit the nail on the head. You have to know where it is and how to get to it and what it's called. And then so finally, just in wrapping up, we talked about computer files and what they actually look like, the differences in volatile and non-volatile memory or storage, what the hierarchy structure of a data system is, whether it's on Windows or Linux, how to use a file. You have to declare it, open it, read it or write, and then close it. How to merge files together, how to read from a sequential file, and what a random access file is. All right, does anybody have any questions? James, do you have any questions so far? All right, good. Give me one moment. I'm going to pull up the assignment for this week. Give me 1 second. Okay, so for the assessment this week, it's in Chapter 7, just like we went to. What we're going to work on is Exercise 1 on page 318. It's actually on page 317, but it spills over into 318. So looking at the book really quick. Looking at the programming example, it says the Vernon Hills Mail Order Company often sends multiple packages per order. For each customer order, output a mailing label for each box to be mailed. The mailing label contains the customer's completed name and address, along with the box number in the form of box 9 of 9. For example, an order that requires 3 boxes produces 3 labels, box 1 of 3, 2 of 3, and 3 of 3. So design an application that reads records that contain a customer's title, for example, Mr. or Mrs., their first name, their last name, their street address, their city, their state, zip code, and number of boxes that they have. The application must read the records until the end of the file is encountered, and then produce enough mailing labels for each order. Right, James, it is a lot more than we've been working with. Okay, so the first thing we're going to do is we're going to start our program. So we're going to say start, and then we're going to essentially declare our variables. So declarations. It asks us to have how many variables? We're going to have two files. We're going to have a customer data file. So we're going to have input file. It's going to be customers or customer data. We're going to have an output file where we're going to put this stuff. That's going to be mailing labels. Then it asks for the string information. So string title, first name, last name, address, city, state, zip code. And you're going to have a integer for zip code and number of boxes they have. And we're going to have one more for the count. Yeah, it was number of boxes for that person. It is the box number. You're right. It's the box number for that particular address, such as one of 9, 2 of 9, 3 of 9. So you're right. No, you said, okay, number for person. No, we're going to keep the number of boxes. We're going to have that be 1 for each person, essentially. All right, so the next piece, we're going to say housekeeping items. So let's say we're going to open customer data. We're going to call this one Vernon Hills mail order boxes .dat. We're also going to open mailing labels. And that's going to be customer mailing labels .dat. We're going to get the input of those to the title, first name, last name, address, city, state, zip code, I meant zip code. Number of boxes. That's going to be from the customer data. Well, we didn't do box number, we just did number of boxes. So we're going to use that. So once we got that information, we're going to say while it's not the end of the file, and while it's not the end of the file, we're going to loop. And inside of that loop, we're going to say, we're going to set our count equal to 0. Then we're going to say while count is less than number of boxes specified. You say count plus plus, or you can just say count equals count plus 1. However you want to write that. We're going to give an output of the title, first name, last name, and we're going to send that to the mailing labels. We're going to output again the address to the mailing labels. We're going to output the city, the state, the zip code to mailing labels. And we're going to say output box count number of boxes. We're going to send that to mailing labels. And then we're going to input all of that from title. Actually, it's going to be all of this again. Right, so the output will be box 3 of 9. Yeah, you're right. And then once we're done with that, we're going to close our customer data file. We're going to close our mailing labels file. And we're going to stop. All right, does that make sense? We start, we open our declarations, we open our files, we get the input from the file, we loop until the file is over, and then we get the number of boxes. You say it's a lot simpler than you thought it would be. Yeah, it's rather simple. Now, the way I did this one, I didn't use any sort of modularity. I didn't break things out like I could have. In fact, this is just a one style program. I could have written it a little differently. I could have said, okay, we're going to take this information here, and we're going to create a list loop, essentially. Return, and I could have called this list loop. I could have taken the, let's see, open file piece, and I could have called this declaring files. Return. And let's see, I needed one more of this right here. And then the last one, which was closing in everything, I could have said finishing program. And it could have closed everything. Return. I could have said start, declare all this info, giving my variables, and then broken it out into sub-programs. Either way works. You're right, James. My first one that I wrote, or that we wrote, is simplistic in nature. It does the exact same thing as this one, the more complex version. The difference is which one's more usable, which one's more sustainable over time. And yes, I would say this one here would be more sustainable because I effectively have 4 different programs. I have 1, 2, 3, 4. In the other one, I have 1 program. So whenever I have to make a change to this particular system or this particular program, if I were using the old style, I would have to always bring the entire system down, make the change, and re-upload it. Where this setting, I can make a change to each module individually and not have to worry about messing anything up. Right, for a higher volume of boxes, most likely. Right. So after looking at this, do you have any questions, James? All right, good. Then look, James, specifically look for an email from me this week about what you asked me about earlier, your networking setup. Um, as for everyone else who's going to be watching this as a recorded session, most likely, don't forget that your assignment or your assessment is due by 11:59 p.m. Mountain Time, and your career integration quiz is also due by Saturday at 11:59 Mountain Time. I have gone through and I have graded all of your assignments and the assessments and the discussions up to week 3. So if you have any questions or concerns, please let me know so that we can get those corrected. If you haven't submitted those, please do so that I can grade those. And I'll be grading your assessment and your career integration throughout the week whenever you submit them, so that if you have to make any changes before Saturday, you have the ability to do so. All right, James, if you don't have any questions, I'll talk to you shortly or talk to you at a later time. And thank you and have a good week.